All right. Hello, Haley. This is the second half of the chapter 1 review. We're going to have a test tomorrow. Make sure. No, this is whiteboards. This is the equivalent of whiteboards. Oh, no.
Can we take our time and absorb this info and then
We are going to take our time and absorb this info as long as it doesn't take past 1:50. Okay, here we go. You're gonna be fine. We've already reviewed for like 3 days. You're gonna be fine. You have your note card. Make sure you have everything on your note card that you need. Okay.
And a review that we can use.
And no, not your review that you can use. Sorry.
I'm really trying to find you.
I know you are. All right, 19 through 24. All of these limits are x goes to infinity or negative infinity, which means you're looking at this column over here. We're looking for Haas if it's a rational function. They may not have a ha. I don't know that I put anything on there. Are all of these functions rational functions?
That's a good question. We'll find out.
What's a rational function?
Come out good. I don't know.
Something over something, right? Yeah. Okay. If I would have just done, maybe I should add that to over here, just in case. If I say the limit as x goes to infinity of 3x squared minus 7x, that's not a rational function. Let's talk about what that would look like.
What is it? What is a
That is a polynomial. A rational function is like one of those over top of another one of those. That's what a rational function is.
So it's a 3x squared minus 7x over 3x squared minus 7.
Sure. Or anything other than that. Like this is a rational function right here.
Over anything?
Yeah. Okay. That's a rational function. Yep. As long as they have x's in the top and the bottom. That's what a rational function would be. Okay. Or like 1 over x. That's a rational function. Okay. So this guy, how would I find the limit of that thing? 3x squared minus 7x.
Can we just plug it in?
Kind of, you can-ish, yeah, maybe.
No,
like you plug infinity in, you can kind of plug infinity in. What? What does 3x squared minus 7x look like? It's a parabola, and he is going to smile, right? So as he goes forever to the right, he is going forever up. So he's going to infinity. That's what the limit is. So you can kind of plug it in, right? Like infinity squared minus 7 times infinity is going to be positive infinity, right? Okay. So
how do we know it's a parabola?
Because 3x squared is the highest power, right? So quadratic is squared.
That it's not really a parabola. We discussed something was like a v and something.
No. X to the 4th power. If it's just x to the 4th power, he is more of a flat tire. But x to the 4th plus 7x squared minus 32x plus 1 is a w. So still the same general end behavior shape, but he has like little humps in the middle if he has extra stuff. So anyway, there's that. Okay, rational functions. So if he's a polynomial, you're just going to look at what his shape is and go from there. Okay, I didn't put any of those on here. I probably should have. 19. How do I do this?
The
leading coefficient.
Yeah, n is 1, m is 1, and n is equal to m, so I look at the leading coefficient, so his limit is going to be?
7 over 4.
7 over 4, you got it. Beautiful. Okay, 20. We're going to infinity. He's a rational function.
0.
We could try to break him down if we wanted to.
M is bigger, so
but it doesn't matter.
0.
N is 1, m is 2, so he is bottom heavy. His limit is going to be 0. He's going to approach 0. He's going to have a horizontal asymptote at 0. Okay? 21. Ooh. What's n?
D&E. Because the top is
5.
bigger.
Look at the 5, right? He's in a bad order. Number 1, he's going to topple over because he's top heavy, which means his limit does not exist. He does not have a limit, or he does not have a ha. Anyway, so the limit does not exist. What?
What would the graph of that?
Like okay, they say that if his n is 1 degree higher than the m, so if this was like x squared, he will have what's called a slant asymptote. Like he'll have maybe a vertical asymptote like over here, and then I'll have a slant asymptote that looks like this, and so he'll look like that maybe. Okay, but if he's more than 1 degree higher, he will not have a slant asymptote. So this one will just have a vertical asymptote at -2, and he'll probably do like the little L thing. So he'll do like one of those.
But if he still exists by
Oh, wait. He doesn't have a ha though. Okay, then he looks like the Hurley symbol.
What?
You know what I'm talking about?
Hurley, like the brand is like
The brand
H,
Hurley.
and, like draw it.
You know what I'm talking about?
Yeah.
No.
Like the Hurley L, maybe? Something like
Does
that?
anyone have Hurley clothing? No.
No.
Look,
Like it's like an H,
You know what I'm talking about? With the like little Hurley?
I
Like
see
Hurley,
your
okay.
H guy. I get
but
it.
it doesn't connect.
We're gonna look it up.
This brand.
Right here. Hurley?
Oh.
You know what I'm talking about?
Your little.
The Hurley H.
Oh yeah.
So that's sometimes what he'll look like as well when he doesn't have a when he has a va but no ha, right? So he might look something like that.
So we're looking at ha's as the limit goes to infinity. Right?
So as he goes forever to the right,
he doesn't have a ha.
he doesn't have a ha.
So he's D and E.
So he doesn't have a limit. Yep. Okay? Alright, 22. This one is a rational function. Ooh, these ones are tricky. We'll do this one and then we'll do the other one.
Conjugates.
Well, no, we don't want to do the conjugate. We're going to infinity. Or in this case, negative infinity.
Oh, but is it D
Okay?
and E still?
If we look at our
but the square root of x squared is x.
the square root of x squared is x, so our n is actually 1 and our m is actually 1. Okay?
But
So we look at the leading coefficients. What's the leading coefficient of the top? The square root of 5. The leading coefficient of the bottom is 1. Now here's the only issue.
You can't do that.
You're plugging negative infinity in. So when we plug look at plugging negative infinity into that bottom. If I plug negative infinity in for x, that's going to be a negative number, right? If I plug negative infinity into the top, the square is going to get rid of the negative, right? But the bottom is going to keep that thing negative, so the limit is going to be at negative square root of 5 over 1.
No.
Or just negative square root of 5. Do you see how that works? Because we're going to negative infinity, he's going to make him negative. Got it? Okay? All right, let's go do, we'll bump back to 23, but let's go do 24 now.
Why are we skipping 23?
What?
Because this one is the same way. Okay, so the square root of x to the 4th power makes my n
X
2.
squared. What
Yep.
x squared, right?
So we got 2 and 2. So n is 2 and m is 2, right?
The square root of
So I look at
two
leading
over
coefficients,
one.
which is the square root of 2 over 1, but we're plugging
But
in
can
negative
you not take the
infinity.
square root
But,
of two?
It doesn't matter.
but, so this yesterday is what I told you, Reese. Maybe I thought maybe since we're plugging negative infinity in here, it would be negative. But the only difference is I'm squaring it, right? I'm squaring it on the top and the bottom, like really kind of, yeah. So the negative is going to go away. So I think it does stay the square root of, or positive square root of 2.
So it's
Yeah.
So because
Let
it's
me graph it.
squared,
Because
Oh,
it's
like
squared,
that.
right?
Because-
Whereas the first one, the bottom was just x, so we just
Yeah.
plug it in.
square
Let me see if I can graph this puppy.
equals positive. Okay. So
2
it's
x to the 4th plus 20
Can you
x.
not just like take the square root of 2? Is there an answer for that? Square root
No,
of
you can't.
two?
So
It's
one-
1.4.121.
Yep, we're right.
5, 6. That's a shame.
This is what this guy looks like. Do you see him? So he's doing like this on either side, and then you've got like a little hump in the middle. Yeah. So this is the square root of 2 right there, where he's leveling out at. So on the right side and on the left side, he's leveling out at the square root of 2.
Plus and minus.
Because, and so that's why he's only positive square root of 2 instead of we're just going to negative always.
Oh,
Okay? That makes sense?
So we just leave him at square root of 2.
So just the square root of 2 is what he looks like, yep. And it's because if we were to plug a negative into there and a negative into there, the square in the 4th power would make him positive again. So that's why he's positive square root of 2. Got it? All right, let's bump back to 23. We're going to negative infinity. How the heck do I do this?
Well,
Is it just like one of those that's
M is
What's
bigger than
n? What's n?
N is 1.
N is
0.
0.
Oh,
M
I
is
thought you were talking about M.
M is 1. N is 0. M is 1. So what's the limit?
7 over
0.
1.
0.
0 over 1.
0.
Just 0.
Just 0. If n
Oh,
is less than
because,
n,
yeah,
then it's
it's
0. The
0.
limit is 0, right? Doesn't matter if he's going to positive infinity or negative infinity. The only time it really matters, positive infinity versus negative infinity, is on the square root ones. Mm-hmm. Otherwise, it's going to be 0 or the leading coefficient or does not exist or whatever. Okay? Good?
Yeah.
All right, so let's go to the next. 25. Find any values at which the function is not continuous.
2.
Okay?
So
What
it-
makes a function not continuous? What things could happen?
Zero on the bottom.
Zero.
Vaz?
Jumps.
Not Haas.
Jumps.
Haas don't make it not
Piecewise.
continuous.
Holes.
Holes. So Vaz, holes, and if he has a jump, which would be like a piecewise function. Those
Okay.
three things make him not continuous.
Yeah,
So
not
do you want to write that on your note card?
not
Not continuous. Not continuous. You're looking for
whole.
Vaz. How do you know it's a va, by the way?
If it
Zero.
didn't equal 0,
The denominator
on the bottom.
equals 0 and doesn't cancel.
Or piecewise.
Okay, a whole is the denominator equals 0, but yes, it cancels. That's when you have a whole. And the third one is a piecewise. That does not overlap. Not every piecewise function is discontinuous. Let me give you an example.
It's
Here's-
just like if
Here's a piecewise function. Let's say I have
If they
x squared
equal
and
each other.
2x. And let's say x is less than or equal to 2 and x is greater than 2, right? If he's going to have a problem, it's going to occur at 2. So we're trying to figure out whether he's doing one of these. Does that make sense? If he does one of those, then he's bad, okay? So what I'm going to do is I'm going to plug 2 in here. And if I plug 2 in there, he ends up being 4. If I plug 2 in here, he ends up being 4. So what's happening is I have this happening, but then I have a closed dot on top of it. That's what's happening instead. Does that make sense? Because these two are the same value, it's overlapping. If they were two different values, I would have a gap. Make sense? Okay, so that's a piecewise function that does not overlap. That's an example of that. Yeah, what?
So if they don't agree, then
If they don't agree, then he's not gonna be continuous at that point. Yes. Good question. Okay, make sense? All right, so let's talk about this guy. Where is he not gonna be continuous at? Negative 2, positive 2. Okay, so x minus 2, x plus 2. So x equals 2 and x equals negative 2. What is happening at 2 and negative 2? Are they both vaz?
Yeah.
Yes. They are both vaz.
Do we have to say that?
You don't have to say that. I'm just kind of like, keep that in my mind. So identify where the function is not continuous at 2 and negative 2. Got it. Okay. All right, next one. Identify where he's not continuous.
X
How would we write
plus
that?
1.
Like x
What's that?
is
Um,
not equal to or negative to? Is that
Zero.
how-
You can say continuous, all rails except, if you want, 2 and negative 2. Or you can just say, technically you could just say x equals 2 and x equals negative 2, just like we said. Find all values of x where it's not continuous. We found the values of x. So you could just leave it as x equals 2, x equals negative 2. But if you wanted to write it formally, you could do it that way. Okay. Find where he's not continuous here.
Just X on this one?
Okay. What can he not be here?
0.
0. X is equal to 0 will give me something bad. What's happening at 0? Va, hole, or gap?
There's a hole, right?
He's a va because he doesn't cancel. He's only a hole if he cancels out. Okay? All right, if I factor this bottom part, or this part here, x plus 1, x minus 1, okay? And if I set him equal to 0, x equals negative 1, and x equals 1, okay? Let's talk about what those are. What's negative 1 going to be?
Negative 1's a whole.
Or
No, it's gonna be a whole because they cancel.
Now,
Hole.
this one cancels.
Yeah.
It's a whole
So
and
x
Oh, yeah.
equals 1. X equals 1 is a whole.
Yes.
That's confusing, right? X minus 1 canceled, so that means x equals 1 is a whole. This one is still a va. Okay, makes sense. So we have two vowels and a whole.
Equals 0, comma, negative 1, comma,
Oh.
1.
Yes.
Why are
Yep.
you saying
No.
So he has two vowels and a whole.
2 vowels, so,
Okay, so he's not continuous at those values of x. Got it?
One whole.
Yeah, very nice. Okay,
Very nice.
now here's another one. This is the third kind. Identify where he is not continuous.
So we plug 4 in
And
for
they
each
did
of
something
those?
tricky to you.
We plug 4 in for the
Okay,
x's.
let's see if he has a gap. Yep, 4 into each one of those. 4 into there, 4 into there.
8 plus 3, 8 plus 3, 8, 9.
11? If we
11
plug
for
4
the
in, we get
top.
11 on the top?
16 divided by 4 is 4. 4 plus 7 is 11.
Yeah.
You betcha.
So he's that piecewise that connects at the same spot, so he is continuous.
So he's continuous everywhere except
0.
for
I don't know.
Yeah.
Josie's right. 0.
What page are we
Why is this one not continuous at 0?
16 over X.
What page are
Yeah, because he has
well,
this
we
guy.
said it couldn't be X, right?
What?
The bottom couldn't be X, so I said 0. But it is X.
Oh, but
has to
wait
be
a
right.
second. Wait a second. This, okay, so we're saying x can't be 0 for
That's
this
where
function,
X is greater
but
than
x is already greater than 4, so he's continuous everywhere.
Yeah.
Alright.
Yeah.
See?
Do you see why
That's
that
why
is?
I didn't think I was right.
Do you see why that is? Okay, you can't have 0 in a denominator, right?
Continuous
But because he's
everywhere.
only defined for greater than 4, that's okay.
Yeah.
Yeah, so he's
just
continuous everywhere.
Continuous everywhere.
So continuous, all reals. He's continuous everywhere.
Are you gonna try and trick us like that?
That was tricky. I don't think so. I will give you a piecewise function, but I don't think I'll put a rational function inside of the piecewise function. I doubt it.
I'm so tired.
Okay. So the fact that he comes out to be 11 on each one means that he's filled in, right?
Yeah,
Makes
he's
sense?
not filled
Okay.
in.
All right, 28. Find the value of k if possible that will make the function continuous everywhere. All right, he's continuous. If he's not going to be continuous, where is he going to have a gap?
0.
At
1.
1, because that's where he jumps from one function to the next, okay? If I plug 1 in here, I get how much?
5. You get 5.
I get 5. If he is continuous everywhere, this guy has to be equal to
5.
5, right? When I plug in
1.
1 goes in for what?
1 goes in for X.
1 goes in for x. Can I figure out what k has to be?
equals 5.
K equals 5.
K equals 5. In order for that to not have any gaps, k would have to be 5. You see how that works? Yeah, that one's not too bad. Okay, I like this question. 29, here are your answer choices, and it can be more than one.
Which one is bracket? Which one is which?
Bracket
Brackets?
means you have a hold on it. The parentheses means you don't have a hold on it.
Yes.
Think like the
Yes.
bracket.
So-
The bracket
Yeah.
has equal sign.
So
in
the
it.
bracket is the
Bracket is a
folded
closed circle, parentheses is an open circle.
Bracket.
Bracket's a closed circle.
So brackets are included.
This sounds sounds
Yes.
really stupid. When you have like inequalities and you have like x is less than or equal to some number, right? Okay, that's a bracket because this sounds stupid. He has a horizontal line on him and he has a horizontal lines here. So I think equal to.
That's a-
You see the equal? He's like an equal sign with a bar on him. Okay, equal sign. I don't know. That's stupid. So, but if it helps you remember, go for it. All right. So we want to know where he is continuous. So is he continuous including 6 and 9?
No.
Including 6, including 9? No.
DC.
So I'm going to cross him off. Okay? I shouldn't do that. I'm going to do that. I'm going to do it like this.
6
Cross him
to
off.
9.
3 to 9. Is he continuous 3 to 9 inside?
Yeah.
Yes. So that one. 6 to 9. Woo.
Is it DC, C, C, C?
6 to 9 inside of 6 to 9.
Yes.
The third one? Yes.
Yeah.
What about 3 to 6 inside? Yes. What about 3 to 6 including 3 and 6?
Yes.
Yes. What about 3 to 9 including 3 and 9?
No.
No, because the 9 is not a thing. Yeah.
Can I go to the bathroom?
Got it? Good?
Sure.
Yeah. We got like 2 left. Can you wait?
I guess.
You guess?
2 left.
Oh, no, we got a
I thought
couple
you just
left.
said
We
you
got a
were
couple
going to
left.
30.
We have a whole page left.
We have a whole page left.
But we're going to 30. Right?
No, we're going all the way
You
to the end.
said to 30.
I said 30 something. I don't know.
6.
I don't know what I said. Yeah. Oh, 36. Okay, we got lots left. We got lots left.
Tomorrow will be a perfect day to finish this.
I agree.
I also agree.
Yeah.
All right, 30.
It's unanimous.
You're gonna be fine.
Coverage.
You're gonna be fine. Find values of x where he is not continuous. Okay, what 3 things make him not continuous?
0.
Holes, vase, piecewise functions. Okay, we don't have to worry about the third one because this is not a piecewise function. So holes or vase.
plus 8, x minus 8.
Oh, wait a second.
No.
It's not
Oh,
minus. Oh, x plus 8,
wait a
right?
second.
X
No.
plus 8.
No.
It's
No.
not a difference.
It's not a difference of squares. It's a sum of 2 squares, which is not a thing. There's sum of 2 squares is not a thing. There's a sum of cubes, but not a sum of squares. So x squared plus 64. All right, so here's the deal. If you want to think about it this way, x squared plus 0 or excuse me, x squared plus 64.
Can you just do x plus 8 squared?
Nope,
That doesn't
nope,
work.
cannot be equal to 0. Because, Josie, x plus 8 squared is x plus 8 times x plus 8,
You have 16 in a row. You have
which is x
16.
squared plus 16x plus 64.
No.
That makes sense? So not the same thing, okay? All right, x squared plus 64. If you look at it like this, we don't want that thing equal to 0, right? Don't want that thing equal to 0. So I'm going to
It's
subtract
imaginary.
64, okay?
Are we doing?
And I'm going to say x squared can't be negative 64, right? And if I take the square root, that means x cannot be positive and negative 8i. X cannot be an imaginary number, which means x can be what?
Anything.
Everything.
reals.
X is all reals.
That's what I was.
Does that make sense? Because you will never end up with 0 in the denominator if you're adding a number to a square,
Do
right?
we need to have the what it can't be the plus or minus
No,
data?
no.
Or can we just
no.
say
This is just like if you don't understand why this can't be all reals, just think of it in terms of like how you would solve it normally. So you don't have to have that there. This is just the justification for it.
Okay.
Okay, make sense?
I guess.
Okay. Rewrite the expression as a single log. Blah.
What is
We've
a
got
single log?
as a single log, one piece. I think we did this exact problem maybe somewhere.
probably
Okay, so you have this guy, and then you have this guy, and then you have the 2 that's just chilling, right? Okay, the 2 that's just chilling, he just gets to chill. But let's figure out where the things go. What would you like to move first? What can we move first?
What moving? Where are we moving it to?
The 2, this 2, where does he go? To the back. Okay, so you can either put him there with parentheses around the whole thing, or do you remember what I said you can do? You can do sine squared of 5x. If you don't like the parentheses, you can do it that way.
Wait, what?
Whatever. So you can either write him like this, or you can write him like this. But don't just square the 5x. Don't just put the parentheses around the 5.
Wait, so do we move the half to the back?
Yes, we can move the half to the back. I'm going to do that. So this is 1/2, but what's the 1/2 power mean? The square root of x.
Wait.
Okay?
I thought we moved the 2 to the back, so why did it become sine 2 to the 5x?
Because putting him to the back is the same thing as putting him here instead.
Oh.
So you can write him either way. I don't care if you put the square here or the square there. We'll put the square there. If we want to. We'll put the square there. Okay? There he is. Alright, now
go
what?
to bed earlier, but
Now what? We still have to combine them together to make one.
I agree with you.
I don't know.
Log
Oh.
minus means
Goodbye.
divide. Minus means divide. Okay, what are we dividing? What goes on the top?
Square root of x.
Square root of x. What goes on the bottom?
Sine squared of 5.
Sine squared 5x. Like that.
why did I write it x to the half?
Okay?
Supposed to.
I'm so
And then plus 2. He just goes on the end because he can't go with anybody.
Where did he come from?
So
Up on the
all
top.
the way back.
Yep, all the way back to the front.
I'm just really confused.
You're confused?
Like, I just like, why can we divide it?
Because it's subtraction.
Yeah, you have 2 logs and minus means divide. So when you combine the 2 logs into 1 log, you
If it was
divide
plus,
with
what
them.
would you do?
Multiply.
Multiply, yeah.
You have
Plus
one
means
of those.
multiply, minus means divide.
Oh, like, what would it be like? Like, what would it look like? Square root of x times sine.
In parentheses, you just do the little dot.
If this was plus?
Yeah.
Oh,
Yeah.
yeah, you would look like log square root of x
Parentheses,
sine
dot.
5x squared
Oh,
5x,
okay.
like that. That's what he would look like if it was plus.
But if it's like a fraction up front, does that just mean it automatically comes up a square root?
Yes. So if it's like to the 1/3 power, it would be the cubic root.
Cubic root.
Mhm.
Oh yeah, that's what I meant though.
Yep, yep.
You
Exactly.
didn't stable my thing right.
Y'all what?
I'm sorry. I don't, did I
I was
staple any
really
of it?
confused.
Oh, no, yes, I did. I stapled yours last, though, because I took pictures of yours. That was the deal. All right, 32.
The last page is backwards, so I was really confused.
Where are we?
32. Simplify the expression without using a calculating utility.
What? How would you know if we
Oh,
would
it's
use
1
our
over.
How would you know if I did?
1 over 3 to the 4th.
1 over 3 to the 4th, which is?
3 times 3 is 9. 9 times 3 is.
No. When you're doing 4s, 3 times 3 is 9. 9 times 9.
Oh,
Right?
7.
1 over?
Wait, 81.
81.
Yep.
1 over 81.
That's what I meant.
Okay? All right. I don't like 1.5. This is actually 25 to the, what's 1.5 as a
3
fraction?
seconds.
3 over 2, but what's 3 over 2 mean?
Square root of 25 cubed.
The square root of 25 cubed. Do you want to cube it first or take the
No.
square root first?
Thanks.
So we'll put the cube on the outside. Yep. So this is 5 to the third, which is
125.
125. There we go.
5 to the third, which is 125.
Okay.
I can hear you writing.
All right. 36. Let's fix him.
Wait, I wanna see.
Negative half.
Negative. This is negative 1/2 power, right? How do I make him positive 1/2 power?
Wow.
1 over 36 to the 1/2 power. What's the 1/2 power mean?
Right, so just
Square root.
squiggle.
Square root. 1 over the square root of 36, which is
6.
1 over 6.
1 over 36 to the half.
I'm
So 1 over square root.
Confusion?
You're so slow. Oh, 36.
90, 30, and 31.
Hold on, we will. Okay. All right, 33. Find the exact value without graphing utility
Wow.
or calculating utility. Call him X.
Can you like on the side? Can you like? I don't know. Like go from log to.
Oh yeah.
other
You want an
ones,
example?
Like yeah.
Log base 2 of 8 equals 3.
Are we gonna have to do
That
anything
means
with
2
the
to the third power
LNEs?
equals 8.
Do we have anything?
'Cause it
to
goes
do
like
with
this.
Oh, we do have stuff with Ellen.
There it is.
No.
So that's an example of that.
I don't understand.
Is that what you wanted or no? Yeah?
Yeah.
Okay.
Wait, hang on.
Okay, we're gonna do that same thing for A and B and C and D right here.
3x equals 32.
Okay, so if I say log base 2 of 32 equals X and I flip that around, he says 2 to the X power equals 32. How many times do I take 2 times itself to get 32?
Don't ask me.
5. X is 5. There you go. Beautiful. Okay, if I say this guy equals X, this means 2 to what power gives me 1 over 64. Okay, let's just talk about 64. How do I get from 2 to 64? To the 6th power. How do I get 1 over 64?
-6.
To the negative 6th power. So X equals negative 6. Does that make sense? Negative power will make him a fraction. Okay, let's call this guy X as well. This says 9 to the X equals 9.
So 9 to the first.
X
One.
equals 1.
0. Okay.
Okay. Also, if you have your base and your base of your log and your base of your exponential function that are the same, they cancel out. But when they cancel out, they don't make 0.
They make 1.
They make 1, right? For that reason. Does that make sense?
Is it half?
What? Oh man. This says 49 to what power gives me 7? How do I go from 49 to 7? The square root, which means half. X equals to the 1/2 power. Look at you guys go. You're so brilliant.
I'd like to differ.
Brilliant.
No, just wait till the next one. Can you like
Wait, what's that?
leave this out on the, don't put this on the test.
Don't put this on the test.
No, that's
34,
easy.
35.
Oh.
Oh, 34 and 35.
35 is easy.
What?
The E's and the LNs.
Oh, I
Whoa, wait, what? You guys
Alright.
find that easy?
Here we're expanding.
I do.
I don't.
How many variables do you have?
So confused.
3.
So we're gonna have 3 ln's.
3 LN.
We have ln
LN,
something.
A
We have
squared.
ln something, and we have ln something. Okay. All right. A goes here, but instead of having a squared, he's gonna be 2 in front, right? You see that?
Why not?
Okay.
Got him? A squared. Okay. Then we have the square root of
Which
b,
is half B.
which is half b,
And then
or
the
b
next
to the
one
half. So this is
half
1/2
B,
ln b.
or
So you see that? Am I going too fast? Okay.
Half,
C.
half LN.
Now this
C
is
to the
technically
third.
c to the third to the half power because
Oh,
that's underneath of
or
that.
3 over 2.
So 3 over 2 goes out front. C. Was that too fast?
No.
Yes.
Yes?
So that's the answer?
Okay.
Why
Did
are
you
we
get
adding
stuck on the
that?
whole thing?
Wait.
Oh.
That's all pluses because we're multiplying. That's all.
Oh, I put.
Do you want me to go through that again?
Mm-hmm.
Yes? Okay. So a squared, the 2 comes out in front, so that's 2 ln a. That one's not too bad, right? Okay. This guy right here, if I break him down, this is b to the 1/2 power, right? Because that's what the square root does.
The opposite of 31.
C is c to the third, but then that also to the 1/2 power, right?
So then you just throw the
Do we
C.
have to put B
Throw-
and C?
Because the square root
yeah.
is over top of the c to the third also. That make sense? So that's how these guys boil down. Okay, so then the 1/2 can go in front of the ln for B, and the 3 over 2 can go in front of the ln for C.
So
you
that's why
combine
he
that
looks-
to
We
3
can
over
just-
that is
Yes,
like the opposite
the 3
of
and the 1
31.
half. What?
That was like the opposite of 31,
Yes,
right?
exactly. We were expanding rather than condensing. Okay? All right.
ln. There's
Okay,
three
there's 3
lns.
pieces. So we've got ln something, ln something, ln something.
All of it subtraction, right?
No,
The
no.
bottom 2
You
would be
have to
adding.
use like
Or
parentheses
No, the last two are
Mine-
but B.
Yeah,
the first
we
2
have
are
to
subtracting,
subtract
or
those
subtracting,
two.
and the last one is adding.
A and C. So like
We need to put
ln
parentheses
minus
around the last
ln
two, right?
plus.
So you have options. You can either do minus this stuff, or you can do minus minus. That make sense? Yeah?
See, I put 2 minus.
Because if I do minus this stuff, I could just distribute my minus through,
Oh, yeah.
right? That makes sense?
yeah.
So we can
Okay,
do minus minus.
So we can do minus minus, so that they know they're both on the denominator. All right. The first one is B,
So 3.
okay, but the 3 goes out in front. The second one is
5.
A, but the 5 goes out in front. The third one is C, but the 3 goes out in front.
B.
I'm really trying to skip some steps here.
Mm,
Am I confusing you by skipping all my steps?
no.
B.
No, that one wasn't too bad because the fractions weren't there.
5A.
Wait. Or never mind, never mind.
Wait.
How do you decide the order of B?
If I put parentheses in there, do I have to have an
What?
addition
B
sign?
divided by.
B is on the top,
Okay.
so B goes first.
So if
Then
put
I just go in order
parentheses
by the
in
way
there,
that I
need
see it.
a addition
Left to
sign.
right, top to
Could
bottom.
you go negative 5 ln A minus 3 ln C?
Yeah,
plus-
technically you could.
Wait, question. Don't you
That
need
is
an
really hard to do.
addition sign
Put them back
between the
together.
A and the C to know that you multiply those?
No, because this
But
is
if you
divided
do
by-
that, if you do addition, then you would have to do this
Why?
so that you know that that's on the bottom. Because if you
Because
don't,
you're dividing
like
by
what Reese just said, okay? Reese just said you could do those in any order. Like you could technically write them in any order, okay? So if I write it like that, I could put this guy first, this guy second, and this guy third, right? So I have 3 ln B plus 3 ln C minus 5 ln A. Technically, when I write it like that,
It's
these
the-
two are on the top
yeah.
together. So that would be ln of B cubed C cubed over A to the 5th. Does that make sense? So you have to note that he is a negative. That he goes on the bottom. Otherwise, if you rearrange them and he's positive, these two look like they go on the top. Make sense? Yeah. That's how he works.
Alright.
That was a lot more than you needed to know, but that's okay. These are good questions. So he has to either be a minus or put parentheses around him. Cancel. Okay, couple more. A. Ugh.
Why do you say ooh?
What will you do first on A?
I
Can
kinda
we
wanna
switch
get
it to the
rid
other
of
form?
the
ln?
ln.
Not
You
yet.
put negative 8x.
Divided by 2.
Divide by 2. Okay, whatever. E to the negative 8x equals 3.5. Okay, now
Now we ln.
you can either ln both sides, so you put an ln in front of each side, or, and this cancels out, so you get negative 8x equals ln of 3.5. Or, Reese said, can we switch him to the other form? Okay, if I switch him to the other form, that would be log base E of 3.5 equals negative 8x, right?
Okay, but
Okay, but log E is ln. So I end up with the same thing here as I did here. Does that make sense?
Yeah.
So you can either think about switching him to the other form, or you can just put an ln in front of both sides and you're going to end up with the same answer, right? And that's why that works. Okay, so last thing I'm going to do is I'm going to divide by negative 8. Okay. All right, make sure you close the parentheses after your 3.5 and then divide by negative 8.
so x equals ln 3.5 divided by 8.
Negative 8.
Oh yeah.
Do we need to, can we use a calculator on this one?
Oh,
Yeah,
wait,
you
that's
have
not
to.
the
Yes,
answer.
yes, yes.
Oh, we have to
No,
solve
no,
for
no. We have to
x.
solve for it. Do they tell you? Yes, go ahead and solve for them.
I was just making sure.
No, this one you have to use a calculator for.
ln 3.5 divided by negative 8. Negative 0.1565.
Negative 0.1566. We'll go 4 decimal places. Usually in log world, they have you go 4 decimal places.
X.
All right, what the heck do I do with B?
Change it.
Change
The other
it?
form.
Yeah, I could change it to the other form.
That's what I did.
That would work.
Yeah.
Okay, that would work. So if I do, this would be what, log base 3 of 7 equals x, right? How do I do that then?
Just plug it in.
You can plug it in by the change of base.
Or divide.
Or I could do log
Log
base 10 of 7 over log base 10 of 3.
Yeah.
And your calculator if you want to,
Aw.
right?
I don't know. I didn't do
Log
it. I have it written out. I just-
7
1.77.
over. Yeah.
1.77. 1, 2.
Yeah. 3.
There you go. Now, you could use the same process as what we did over here in ln, both sides, right?
1.77.
ln, right? If you ln both sides, now what can I do with the x?
Bring it down.
Move it to the front. So this is x times ln 3 equals ln 7, right? To get the x by itself, I divide by ln 3. Divide by ln 3. So I have ln 7 divided by ln 3, which is the same thing as log 7 divided by log 3. Yeah, either way works. So I'm going to get the same answer. There's lots of different ways to think about it, and it all works out.
I thought about adding the ln, but I didn't know how to get to that.
Yep.
Last.
You can always ln both sides. As long as you do it to both sides, it's legal. All right, a satellite that requires 10 watts of power to operate at full capacity is equipped with a radioisotope power supply whose power output in watts is given by the equation that stuff. Can you say that that's negative T over 125? Okay, where T is the time that is supplied. Okay, what is the operational lifetime of the power supply? What the heck does that mean? What are we solving for?
The lifetime.
Lifetime, what variable is
T.
lifetime? T, we're looking for T. Okay, well that's what we want to find. And
multiply 125.
what do we plug in for P?
P times 125 is equal to 75.
Hold on, but what is P?
10.
P is 10. Right? Because 10 watts to operate at full capacity. Okay, so 10 equals 75 e to the negative T over 125. Okay,
So that
What by 75?
E is to that power. That's the
yes,
power.
E is to that power. So we have to get him down out of there.
Multiply by.
Okay, we're going to divide by 75. What's 10 divided by 75? I know what 75 divided by 10 is.
Divide by
7.5. Oh wait.
Can we not? Can we
What?
just leave
Never
them
mind.
alone for right
10
now?
divided by
and-
75
I'm
is
sorry.
0.13 repeat.
0.131313 or 1
No,
3
1.3333.
333. Okay, we'll go 13333. Okay, equals E to the negative T over 125.
Ellen.
Now we can ln both sides. ln, and the E cancels out. Okay, so I've got ln of, and if you don't want to write all these steps down, you don't necessarily have to, equals negative T over 125. Now what do I do to find T? Multiply by negative 125 times negative 125. Okay, T equals how much?
338.51.
LN.
338.51, and that is in what?
Days.
Days? Oh, round your answer to the nearest day. So 339 days.
What?
What did you get? How did you get that?
I got
I didn't
251.
round my P.
I got.
I didn't round my P.
Neither did
I
I.
left it as a fraction.
Neither did I.
Wait, what? 10 divided by 75.
Did I do it wrong?
I don't know.
I got
Did you
250.
retype your 0.133?
51.9.
LN over 2 over 15.
I got 252.
Yeah, same.
I got 252.
Then what did I don't know what's happening in my calculator then. Did I write something down wrong?
I get
What is the
Negative.
lifetime?
you did 1 divided by 15 years.
wait what?
That's it as a fraction, wasn't it?
252?
I don't know.
Oh,
Is it negative 52?
No, you have to divide by negative
Yep,
125 to get
Okay, well, okay, sorry. So what is it?
It's 252.
You can negative
252?
Multiply by negative-
Well, that's the
Nine.
rounded.
You
Yeah,
multiply
that's
by
fine. I'll just
negative
put 252.
125?
Yeah.
Okay, 252 days. There we go. Hey.
Times
So-
negative 125.
Beautiful. You're gonna be
Oh,
just
wait.
fine.
Well, you're a liar.
Yeah, 10 over 75.
just fine.
right?
I would be
Oh,
just fine if we had an
that's
extra day of paper so that I
But
knew
then
I
you'd
could
be
do it on my
dreading
own.
it.
75 over 10.
No,
Then you'd be
'cause
dreading it.
That's very.
I did all of this with you. This
Well, I
was
delay
your
it
brain
inevitable.
power.
Where?
We are so ready to move on to derivatives. It's so
No.
exciting, and we're so excited. We don't want to prolong it anymore.
Oh, goodness.
You're gonna love it. You really are. You're gonna really like derivatives. I'm so excited to teach them to you.
Are we actually gonna?
Do you like
You are.
teaching
You
them,
are.
or-
I like teaching derivatives
Are
so
they
much.
easy?
Yes, they really are.
Okay,
It's
then
like
I will
it's like basic math.
Okay.
Like I could teach it to you right now, like this
So why don't
power
we
rule,
start
and
with
it's so
these
easy.
Suppose I should actually.
Alright, where's mine?
I could have done that, and you wouldn't have to get up.
Yeah, but just doesn't know how to
Oh,
communicate.
Bye, Haley.